All right, so let's take a look at our packet that we've been. Make sure your name's on it. Make sure you have your period, and your teacher obviously is me, Mr. Jensen. So that'll be on there, and put your name on your packet. When we look at this thing, the inside of this booklet is our goals. Our first goal is I can draw a model that shows the direction the Earth is rotating and revolving around the sun. If you could draw me a picture that shows that, and you said, I could do this so well, Mr. Jensen, I could show you, then check that box right there. If you say, I can almost do this by myself, check that box. If you're saying, no way, Mr. Jensen, I don't get this at all, check that box. That's before you start this booklet. Goal number 2, I can create a diagram and label the seasons occurring on Earth at different places in its rotation around the sun. If you can do this and list the seasons, holy cow, that's pretty good. If you can't do this at all, click this one. If you can do this by yourself, click that one. If you can show me, click that one. We'll see where you're at, wherever you might be. This is just to see how your learning's going. Next goal is right here. I can explain why the Earth experiences different seasons. I can explain it, and I can also tell you what causes 24 hours to happen for a day and a night. Well, if you don't get it, click right there. If you do get it, check that box. Goal number 4, I can use daylight data to determine the solstice and equinox. Holy cow, that's pretty crazy. I can also explain the different amounts of solar energy received at the poles and equator due to the curvature of the Earth. Ooh, okay. If you can use daylight data to get the equinoxes and solstices, then you're probably right here. I could do this by myself, maybe even show Mr. Jensen. If not, click that one right there. If you can understand the different solar energy at the poles versus the equator, and you know how to explain that, then you're probably right here. If not, you're down here. Okay, before we start this thing, just check out where you're at. All right, let's turn to our first page. How does Earth travel through space? It says right here from our reading, the study of the moon, stars, and other objects in space is called astronomy. People who study objects in space are called astronomers. They study the movements of the sun and the moon. Well, what do we call people who study the moon, stars, and other objects in space? What do they call that? They're called astronomers. That's what people are called that study that. Early astronomers thought the Earth was standing still in space and that the moon and the sun, or the sun and the moon, were moving. Wrong. They thought this. Wrong. I could see how, though. They're looking up in the sky. They see the moon go through the sky. They see the sun go through the sky. They're thinking, we're just standing still. Nope, that's not right. How did early astronomers think the Earth, moon, and sun were moving in space? They thought that the Earth and sun were different, comma, the Earth stood still, the sun moved. They thought that the Earth and sun were different. The Earth stood still, the sun moved. Now, that's not right. That's not right. The sun and moon seem to move mainly because Earth is rotating on its axis. That's why it seems like the sun and moon are moving, because Earth is rotating on its axis. That's the imaginary line that passes through Earth's center and the north and south poles. If this is the Earth, I created it with this pencil. It's an imaginary line that comes out of the North Pole, goes right through the center of the Earth, comes out the South Pole down here. This pencil is like an axis right here. That's what we call the axis. And the Earth, if I was to hold the axis, the Earth spins around that axis. It's spinning around. That's what gives us daytime and nighttime. If we're the sun and we see America right here, U.S., we'd say, oh my gosh, here comes America, daytime. Nope, don't see it, nighttime. Oh, there they are, daytime, nighttime. That's how that works. The sun and moon seem to move mainly because the earth is, that's the word we're looking for, rotating on a certain point called the rotating on its axis. The spinning of Earth on its axis is called its rotation. The Earth's rotation on its axis causes day and night. It takes Earth about 24 hours to rotate once on its axis. How does the Earth's rotation on its axis affect us? It causes the Earth to have, what was it again? Oh, day and night. Earth's rotation causes, that's the word, causes day and night. Well, if this is the sun shining on the Earth, then if you're on this side of the Earth, you're in the sunshine. But if you're on the back side of the Earth, you're in the dark. The Earth is spinning on its axis 1,000 miles an hour. The Earth spins on its axis once every 24 hours. 365 times in a year. We have 365 days. All right, once you got to this location, you were to get a stamp from Mr. Jensen. And since you're at this location, I'm going to stamp my booklet just like that. Hopefully you'll come up to me and get yours stamped. And let's keep moving on. Super important thing to remember. Oh, there's that monkey's face. What? The Earth is not straight up and down while moving around the sun. Huh? Nope. There's a picture of it right here. It's actually tilted sideways, just slightly. It's not straight up and down. It's beep, tilted just a little bit sideways. Oh, the Earth is actually tilted on its side a little. Ooh, put a star next to that. That's important. The axis tilt. You can see here's straight up and down, 0 degrees. Here's 10 degrees, barely tilted, barely tilted. There's 30 degrees. There's 20 degrees. You see how it does that? 0, 10, 20, 30. We're tilted 23.5 degrees. So we're like right here in our little section. The northern axis, or the North Pole, always points to the North Star Polaris as the Earth goes around the sun. All of these north poles are all pointing towards the North Star called Polaris. They're always pointing that direction. No matter where you're at on your revolution around the sun, you're always pointing to the north. Did you know that scientists have come up with the math to show the Earth is traveling around the sun on its orbital path at about 65,000 miles per hour? Holy cow, we are zooming. Well, if I was to take my Earth and I was to show an example of what this looks like, it would look something like this. Here's the Earth. Let's say I make this right here the sun. This is the sun. The Earth always tilts its axis towards the North Star. So the North Star is going to be way out up in here. Let's see if I can. So as the sun is here, tilts towards the North Star, it keeps pointing up towards the North Star, always. Always points towards the North Star. Always pointing towards the North Star. Always pointing towards the North Star. Always pointing towards the North Star. No matter what, always pointing towards the North Star. It never changes. It always points to the North Star. That's super important to remember. Okay. Another stamp. Way to go. Now this one. If I have a lamp shining bright like this, and I have a solar panel, the light will turn on a solar panel because of that energy. If my light is straight on to a solar panel, then it's going to make it bright. That light's going to be super bright. But if I take the solar panel and I change the angle of it, well, that light gets stretched out a little bit differently. It's not straight on. And all of a sudden, that light is less bright because it has less energy. The energy has to stretch itself out, so you have less direct energy. How does the changing angles of the solar panel and lamp affect the brightness of the Christmas light? When the solar panel is straight on, it's bright. When the solar panel is angled, it's dim. Why does the Christmas light get brighter or darker? Different amounts of light change the amount of energy. Less energy, darker light. More energy, brighter light. Last stamp right there. Okay, we have now finished day 1, and we're now going to work on day 2.